So, good morning, all. Here I'm going to start a particular topic on cryptography. So, one of the most important topic in cryptography is symmetric and asymmetric key cryptography. So, we are going to discuss this particular topic, which plays a very important role in cryptography. And coming to myself, I am P. Kalyan Chakravarthy, Assistant Professor, CSE Department, AIML, uh, in GUIDE. Right. So, the today's topic is conventional key crypto system, and the course is cryptography and network security. So we'll go to the topics that are to be covered in the coming slide. So coming to the outline and the topics that are to be covered in cryptography and network security. So here you can see the first topic is introduction to cryptology. So we have discussed cryptography, but now the terms are a bit different, right? Cryptology. And next, the topic is model for network security, which is like the basic model for any crypto system to be developed in future. And symmetric key cryptography, asymmetric key cryptography, and list of algorithms that comes under symmetric key cryptography, and list of algorithms in asymmetric key cryptography. And finally, we are going to conclude it. So this is the overall outline of how our topics will be further proceeded, right? So we'll see the next slide. Thank you. So welcome back. So introduction to cryptology. So this particular term, cryptology, is the combination of cryptography and cryptanalysis together. We call it as cryptology. So in this definition, you can see that cryptology is a study of mathematics. Okay, so the most important subject that we have to learn to understand cryptography or cryptology or cryptanalysis is mathematics. Okay, and mostly it will be working on the number theory, and then based on some formulas and algorithms that together we consider as cryptography and cryptanalysis. So cryptology is cryptography plus cryptanalysis. So 1 plus 2 is equal to 3. Right? So 3 is 1, that is cryptography, and 2, that is cryptanalysis. Combined together, we call that as cryptology. So it is a study of both cryptology and cryptanalysis, considering the mathematical terminology, mostly the number theory, formulas, and algorithms. And coming to the subpart of the cryptology, that is cryptography, right? So this is what we call it as 1, and this is 2, the cryptanalysis, and then finally this is 3, right, which is cryptology, which is a combination of 1 and 2, cryptography and cryptanalysis. So what is cryptography? So which is part of our course, right? So cryptography is a study of secure communication techniques. So here you can see this is a secure communication techniques that happens between sender and receiver for message exchange, right? And what are the methods and techniques will be finding it later, but now how the cryptography is derived, right? So it is derived from the Greek word that is crypto and graphy. So crypto means hidden, and graphy means study. So you're going to hide something, and that study is what we call it as cryptography. So I hope in computer science engineering, this is the oldest subject, where from 18th century there is a concept of this cryptography to protect the information, and kings used to transfer data among one another with these techniques, right? And coming to cryptanalysis, this is a new dimension where people are now focusing more on cryptanalysis, that is code breaking. So here in cryptography, you are trying to generate an algorithm, and that algorithm has to be uh, hacked, or it should be break. So that code breaking technique is what we call it as cryptanalysis. So this cryptanalysis is a study of ciphertext and ciphers, and finally the crypto system. So all these three are the parameters for the cryptanalyst to try to find out what is the algorithm and what is the key that is used to find out the key and the algorithm that is used for message encryption, right? And these are right finding and improving the techniques for defeating and weakening the algorithm. So this is what the cryptanalysis work. So I hope you understood the basic terminologies that we are going to use in this particular concept of cryptography. One, cryptology. Second, it is cryptography and cryptanalysis. Once again, cryptology is a combination of the study of both together, that is cryptography and cryptanalysis. So we'll go to the further slide. As of now, I hope this cryptology concept is clear. So here we see the model of network security. So this is a basic backbone diagram for the security algorithms that you are going to study or develop in future, right? So this is a basic model. This is like a blueprint for any algorithm to be uh, used, right? So here in this model for network security, you can see some of the keywords that they are the technical words that they are using in this diagram, right? So here you can see there is a sender, right? So here the sender is there, who's going to have the message, and using this security related transformation, this is the technique that he is going to use in order to encrypt that message. Okay, so secret information is a kind of key that is used to encrypt the data. So here you can understand that security related transformation, which we generally use the technical word for algorithms, and finally secret information is for the key. So using these two parameters, you can convert the particular message into a secure message. So this is the output that you're going to get, and the message is generally, in general terms, it is called plain text, and secure message is ciphertext. So I hope the model is clear at sender side. Now this particular secure message is transferred into information channel. So here you can see the information channel where the message has been transferred, and the reverse process you can see in the receiver side, right? So what is the reverse process? He is going to take the same secure message, and using the security related transformation and the secret information that is shared among sender and receiver, and he'll get back the plain text message. And why this particular thing is called crypto system is, here you can see in the information channel, while the message is transferred, there are opponents who are trying to access the information, and these opponents generally we call them hackers, crackers, so cryptanalysts. So these people will be trying to break or identify what is the algorithm that is used and what may be the key and the key parameters. So, and one more important terminology here is trusted third party. So the secret information that is shared between sender and receiver, here the trusted third party will take care of the duty, and trusted third party is arbitrator or distributor, those who are going to take care in distributing the secret information among sender and receiver. So I hope the overall concept of model for network security is clear. So we'll go to the next slide. Thank you. So now we are going to the first technique, that is symmetric conventional single key cryptography. So the name itself says that you are going to use single key, which is the secret information in the model for network security. We have seen the previous diagram, right? So that particular key here you can see that this is the secret key that is shared among the sender and the receiver, right? It is a same key or single key or secret key. So there are different names that are given for this particular key, which is shared by trusted third party, right? And now coming to the process of this particular symmetric key cryptography, here you can see in the diagram that the sender will be having a plain text which is acting as an input, and then they will be using the encryption algorithm, which we generally referred in the previous slide as security related transformation. So in that security related transformation, this encryption algorithm is considered as that part. Okay, so this particular encryption algorithm will make use of the key and the plain text, and the ciphertext will be generated. So here you can see that it is a ciphertext which is in the encrypted form, which generally referred as scrambled message. So this scrambled message, if any person in the network or the opponent who wants to access this information, he will be only getting the scrambled message, which is a ciphertext, which is unreadable form, so that the message is secure. And in the receiver end, the receiver will be using the same key, and in the decryption algorithm, with the help of the decryption algorithm, he'll get back the plain text. So this is a general procedure for this symmetric or conventional or single key cryptography. the most important terminologies here is you're going to share a same secret key among sender and receiver. So encryption algorithms can be many. There are n number of algorithms that in the coming slides we'll be seeing what are the algorithms that come under symmetric key cryptography. Thank you. So this slide is also extension of symmetric key cryptography. And here the basic terminologies that we are going to use are ciphertext. Here you can see the terminologies that we use, right? So it is ciphertext, right? Ciphertext, which is also called as coded message or scrambled message, which is unreadable form for any of the person who tries to understand what is a ciphertext. He cannot understand what is a ciphertext because we are using the key and the algorithms to get the ciphertext as output. And now this is the cipher. So algorithm for transforming plain text to ciphertext, which we generally call it as encryption. And then the most important parameter is a key. So key where the information is used in encryption, which is only known to sender and receiver, right? So encrypt or encryption, which is converting plain text to ciphertext, and decryption is recovering recovering plain text from ciphertext, right? So in decipher we'll get back the plain text, which is our output, and the input for that decryption is ciphertext. And as usual, we have seen the cryptography, cryptanalysis, and cryptology in the previous slides. So I hope by this you have come to a conclusion in understanding the technical terms that are used in symmetric key cryptography. So we'll go to the next slide in the coming session. Thank you. So these are the mathematical formulas. Here you can see that symmetric key cryptography, there is a continuation. This is the third slide under a symmetric key cryptography. So at sender side, so what is the formula and the, how you're going to represent a formula. So here with the different colors, I have tried to elaborate what is a formula that is used for encryption at sender side. So here you can see y is equal to, here you can see that y is equal to encryption of, or we'll take another color. So here you can see that y is equal to encryption of k and x as input, right? So x we call it as plain text. Here you can see that x is a plain text, and you're going to take the encryption algorithm E with the help of a secret information or the key, which we call it a secret key or same key. With these two, we are going to convert that into the ciphertext. So here y is ciphertext, x is plain text, and k is a secret key or shared key or same key, and E is a encryption. So with this, you have understood what is the terminology that is used at encryption at sender side, right? And now coming to the receiver part, that is decryption at the receiver part. Okay, so here we are going to take the ciphertext as input, and using the same key and the decryption, we are trying to convert back the ciphertext into plain text, right? So here you can see that x is a plain text and y is a ciphertext, and then k is a secret key, and D stands for decryption. So I hope you understood the mathematical representation or the mathematical formulas of how to represent a particular symmetric key cryptography, encryption and decryption, right? Thank you. So this is a next concept, that is asymmetric key crypto system. In asymmetric key crypto system, there are two security services that are offered by asymmetric key crypto system, which is also called as two key crypto system. So basic terminologies here are, here you can see that they are plain text as usual, which is the input for the sender, and encryption algorithm, which is also the center side work, and here the public key and private key. So this is a important concept in asymmetric key crypto system, whereas in crypto system we have seen that it is shared key or secret key. But now coming to this asymmetric key crypto system, the terminologies that they are going to use is public key and private key. So these are the pair of keys that are given by every user in the network. So whoever in the network, if they want to make use of this particular asymmetric key crypto system or asymmetric key cryptography, they have to generate two keys, that is public key and private key. So these public key and private key are the pair of keys, and one will be shared with the sender and another will be shared with the receiver. So here you can see that it is a pair of key. So here it is a pair of key, and then one is used in encryption and the other is used in decryption. So this is the actual principle for generating the private key and public key. So the transformations can be done from plain text to ciphertext and ciphertext to plain text by this pair of keys. And now coming to the next terminology, that is ciphertext. As usual, it's a scrambled message or coded message which cannot be readable by any user in the network. And finally, decryption algorithm, where you will get back the plain text from the ciphertext. So in decryption algorithm, the input will be the ciphertext and the output will be the plain text, right? And the corresponding public key and private key, the corresponding pair has to be used in encryption and decryption. To understand this further, we'll see the mathematical representation or the mathematical formulas in this asymmetric key crypto system. So in this diagram, you can see the security service that is provided is authentication. So blindly, there is a principle in authentication that we are going to use sender's private key in encryption and the sender's public key in decryption. So here you can see in the diagrams. So here the sender is the Bob. So Bob is going to use his private key in encryption, and the Alice, who is a receiver, will be using Bob's public key at decryption. So here you can see this particular X, which is a plain text. Using this Bob's private key, you're going to generate the ciphertext. So how the ciphertext Y is generated? By taking the input, that is private key of Bob, with that of X. So X is the plain text. So using these two, using the mathematical algorithm encryption, you'll get back the ciphertext, and that ciphertext is transmitted over a secure channel to the receiver, and the receiver will be making use of the public key of Bob from the available public key ring, so that he will get back the ciphertext, plain text, from the ciphertext. So this Y is a ciphertext making use of the Bob's public key. You are going to get back the plain text, right? So here the receivers are Bob, sorry, sender is Bob and receiver is Alice. So here you can see that Bob's private key and public key are the pair of keys that are used in this encryption and decryption, and this particular service we call it as authentication. So most important thumb rule for asymmetric key crypto system under security service authentication is, in encryption we are going to use sender's private key, right? So here you can see that under authentication security service, how the formulas or mathematical representation is represented at sender side as well as receiver side. So here we are going to take a different color, right? So here it is sender side, which means Bob side. So here we are going to take the plain text X with the help of the private key of Bob. Using encryption, you are going to get back the ciphertext. This is done at the sender side, and this ciphertext is generated over a secure channel, and it will be delivered to the receiver, who is Alice, and Alice also may be using the same Bob's public key. So here you can see the input is ciphertext, and the key is public key of Bob. Using decryption, is going to get back the plain text. So this is a mathematical representation under asymmetric key crypto system where the security service is authentication. So under asymmetric key crypto system, now the security service is confidentiality. So in this confidentiality, the thumb rule is the sender will be using the receiver's public key. So this is a thumb rule to understand the confidentiality in asymmetric key crypto system. So now we'll see the diagram. Here in this diagram, this particular Bob will be making use of the Ali's public key. So here you can see that it is Ali's public key, right? So Alice is a receiver, and the receiver's public key he is going to use in encryption side. So here this is what we call it as public key ring, where all other users in the networks, their public keys will be in this particular ring, in which this particular Bob can make use of Alice or Ted or Mike or Joy. So all these are the users that are there in the network, but since he is interested to send a particular secure message to Alice, he is going to use the Alice public key at the encryption or sender side. So here you can see this particular PUA, which is a public key of Alice, and X is the plain text. So we are encrypting it in order to generate Y, which is the ciphertext. And this ciphertext will be given to the receiver, who is Alice. So she is Alice, and that Alice will be making use of the private key of Alice. I mean, like receivers private key with that of the ciphertext to generate the plain text. So this is at the decryption side. So once again, the thumb rule is at the sender side, we are going to use the receiver's public key, and at the decryption side, they are going to use a receiver's private key. So these two keys are generated by Alice, who is a receiver. So coming to the terminologies, in asymmetric key crypto system, where the security service is confidentiality, here you can see that the formula or the mathematical representation at the sender side as well as the receiver side. So here we are going to make use of the receiver's public key. So here you can see PU Alice, which is the public key of Alice, and X, which is a plain text, and you're going to encrypt it, which you're going to get back the ciphertext as output. And this output is shared over a secure channel to the receiver. So the receiver is Alice, and a receiver will be making use of his private key with that of ciphertext that is given as input, and finally he'll get back the plain text. So I hope the mathematical representations are clear for symmetric and asymmetric authentication and asymmetric confidentiality. So these are the three important models or crypto systems in which you can provide security to any information in a communication channel, right? So here these are the list of symmetric and asymmetric key cryptography algorithms. So under symmetric key cryptography algorithms, here you can see data encryption standard and advanced encryption standard, blowfish, double DES and triple DES, followed by IDEA. So these are the algorithms that come under block ciphers. So block ciphers is generally the multiple of 32-bit. So 32-bit, 64-bit, 128-bit, 256-bit, 512-bit. So it is going to be doubled, right? So 512 plus 512, it is 1024-bit, and 1024, it is 2048-bit. So it goes on. So that we call that as block ciphers. And now coming to stream cipher will work on bit level, and block cipher works on block level. So stream cipher works on 8-bit. So this RC4 is an algorithm which works on stream bit level. And coming to the asymmetric key cryptography algorithms, the most popular algorithm is RSA, and then Diffie-Hellman key exchange, then elliptic curve cryptography, Elgamal cryptography, and DSA. So these are the possible algorithms that come under asymmetric key cryptography. So by this, I'm trying to conclude that we have studied the terminologies that are used in cryptography, and then followed by the model for network security, which is like a blueprint or the backbone for any particular new model that is going to develop in future. And followed by that, we have seen the symmetric key cryptography and then asymmetric key cryptography, under which there are two types, which is authentication and confidentiality. After that, we have listed what are the algorithms that come under symmetric key and asymmetric key encryption algorithms. So coming to the last slide, that is conclusion side. So the first point that has to be addressed is symmetric key or one key or conventional key or private key or secret key or shared key cryptography. Everything will make use of just one key that is shared between sender and receiver, and that particular key we called as again one key, session key, secret key, same key, private key, which is used in encryption as well as decryption. So I hope the first conclusion point is clear with everyone. And coming to the second type, that is symmetric key, which is going to use two keys, or we also call it as two key public key cryptography, which consists of private key and public key in encryption and decryption. So under this we have seen two categories, that is authentication and confidentiality. And now coming to the terminologies that we are going to use in symmetric key. Here in the mathematical representation, here you can see that the representation I generally used are x and y for plain text and ciphertext, but for the first time I'm using here C is equal to E of k comma p. So P is a plain text, K is a key, that is secret key, and E is an encryption algorithm, and you'll get back the ciphertext. And in the reverse process, in the decryption side, you're going to take the ciphertext as input, and making use of the same key that is shared between sender and receiver, you'll get back the plain text. And now the terminologies that you're going to use in asymmetric key are a slight difference. So that is KE and KD, because these two keys are not unique, they are different keys. That is the reason why we are going to represent it with KE. So that is a key that is used in encryption, and KD are the key that is used in decryption. So these are the pair of keys, that is KE, right? So KE and KD. So these are the pair of keys that are used in asymmetric key encryption, right? So these are the pair of keys, right? So this is an important mathematical representation. And then coming to the symmetric keys are very quicker than asymmetric key, because asymmetric key requires huge memory and resources than symmetric key. So symmetric keys are faster than asymmetric key. And finally, the symmetric key is indeed one of the fastest encryption technique, but like the keys need to be exchanged securely to be effective. So asymmetric key is the exchange of keys are involved. So this is all about the conclusion points of this cryptography. Thank you. Thank you so much for listening to my online video e-content lecture on cryptography. Thank you all.